Hi folks. Today we're going to look at some definitions for velocity and other rates of change when we talk about kinematics or mathematics of motion. And we're only doing this in one dimension. So often if we talk about velocity, we'd be talking about vectors. But since we're only in one dimension, we can probably get away with just calling them functions. And they can be positive or negative, but that may cause us some issues, especially if we don't have much of a physics background. So I'm talking about motion that is happening on a line. You could go forward on a number line, essentially, or backwards. Just think about a number line. So if we say position, often the variable that's used for it is s for spatium. So if s is negative, if position is negative, that means that we're over here to the left of the origin. If position is 0, that means we're right at the origin. And if position is positive, then that means we're somewhere over here to the right, or ahead or up from the origin. Velocity is the first derivative of position with respect to time. So if we have a negative velocity, that means that we are traveling leftward. Most sort of axiomatically, it means that position is decreasing. The number for position is becoming a lower number. Not necessarily a smaller number in terms of magnitude, but lower. If velocity is 0, then that means position is not changing. That means you're at rest. And if velocity is positive, well, if velocity is positive, then position is increasing, or you're moving to the right. And we're going to have some examples of this in a non-screencast version in just a second here. But I just want to put these out here as ways that you can hack or think about some of these questions. So position being positive means to the right of the origin. Velocity being positive means position is increasing or you're moving right, or depending on the one dimension we talk about, up or forward. Okay? But this is all in one dimension. Now, acceleration is the one that often causes issues. So acceleration is the first derivative of velocity. It's the rate of change of velocity, very strictly, or the second derivative of position. If acceleration is negative, that means velocity is decreasing. But that doesn't necessarily mean that you're slowing down, and we'll get into that momentarily. It means that the number for velocity is going down. So if your velocity was -2, and now it's -5, well, then acceleration is negative. The number for velocity has gone down. If acceleration is 0, that means velocity is not changing. It means you're at constant velocity. Okay? And that velocity itself could be 0. So if you're not moving at all, both velocity and acceleration are 0, if you're just sitting there. But also if you're moving at a constant rate, then there's no acceleration. And again, this is in one dimension. If we get this out beyond one dimension, a good definition of acceleration is either a change in speed or direction. Lastly, if acceleration is positive, that means that velocity is increasing, which might mean speeding up, but not necessarily. So let's define speed now. Speed is the absolute value of velocity. And if you've done some physics, that probably looks familiar. Maybe you had a vector on the v. Okay, so if the velocity is 10 meters per second, that's velocity, then speed is also 10 meters per second. If velocity is -10 meters per second, well, speed is still 10 meters per second. Think about the speedometer on your car. It's not a velocitometer or something. It only tells you the bigness of how fast you're going. So when you pop it in reverse, it doesn't suddenly say, oh, now you're going -5 kilometers per hour. It only tells you about the size of the speed that you're going, nothing about direction. Okay, so speed is the absolute value or the bigness or magnitude of velocity. Now let's think about speeding up and slowing down. Let's imagine that your velocity starts off at like 5 meters per second. and it becomes 8 meters per second. Okay. Well, then you're speeding up because your speed went from 5 meters to 8 meters. And it would make sense in that case that acceleration is positive. Right? Velocity is positive, acceleration is positive, you're going to be speeding up. And you might be inclined to say, well, what if instead it went from 5 to 2? Well, then acceleration is negative because velocity decreased, and in that case we'd be slowing down. The part that tends to cause grief, and again, we'll have some nice demos of this in a minute, is what if your velocity started off at negative 2 meters per second, and then it became negative 10 meters per second? Well, your speed would be going from 2 meters per second to 10 meters per second. I think unequivocally in this case, you're speeding up. You're just moving left as you do it. But if that's the case, then in this case, acceleration is actually negative. So negative acceleration does not mean slowing down. It means the number for velocity is going down. Going from negative 2 to negative 10 is going down. So what are some rules that we can generate around speeding up and slowing down? Well, here's what it boils down to mathematically. And again, we'll flesh this out with some examples. You're speeding up if velocity and accel have the same sign, which means both positive, or they could be both negative. That means they're kind of working together. Slowing down means velocity and acceleration have opposite signs. They're kind of working against each other. We are never going to use the word decelerate. Okay? We're talking about acceleration, and it can be positive or negative. Couple of last sort of tidbits here. Displacement is the net change in position, or you can just call it as change in s. Okay. Distance travel is the total distance an object has covered. And distance travel, kind of like speed, has to be positive. Think of the odometer on a car. It only goes upwards. If you've ever seen Ferris Bueller's Day Off, they try and get the odometer to go backwards by running the car in reverse. It doesn't work. So I'm just going to give you a quick little setup here. Imagine that you started off here at school and you went 700 meters eastward, and you went to the store, and then maybe you went 200 meters westward, and then that's where you got the bus. Okay. Your change in position in this case would be 500 meters, positive 500 meters. It would be where you started from, which is 0, okay, and that would be subtracted from where you end up, which is 500 meters from where you started. So the net distance, net change in position would be 500 meters. That's displacement. The distance that you travel, though, is sort of the number of footsteps that you covered, would be 700 meters plus 200 meters. And really, it's this drawing that helps us figure out that even though in the end you only end up 500 meters from where you started, you've traveled 900 meters. All right, this is all pretty abstract, so let's take a look at some examples. Now let's try and make some sense out of all this, using some stuff I found lying around my house. So here we have a position graph. 0 is the origin. To the right of the origin, we have positive position values. To the left of the origin, we have negative position values. Let's start by looking at the simplest case, where velocity and acceleration are both 0. Here we have Voltron with a position of 0, that means he's right at the origin, velocity and acceleration of 0 because he is stationary. Here he is, still with a velocity of 0, but with a positive position. And here he is with a velocity of 0 and a negative position. We can infer that acceleration is also 0 because velocity is not changing. Let's now consider a case where position is going to be changing. So I'm going to get Pom Pom the panda to walk across, and I want you to think about what's happening with position, velocity, and acceleration. Clearly, position increased. It went from negative to positive. What does that mean for velocity? Hopefully you came to the conclusion that velocity is positive when we're moving to the right. How about acceleration during Pom Pom's adorable march? Aside from the instant when she started moving, acceleration should be 0 because the velocity did not change. She moved at a constant rate. Now let's get Pom Pom to move the other way and see what that means for position, velocity, and acceleration. In this case, she once again moved at a constant velocity, so aside from when she just started moving, acceleration was 0. Apparently she wants to move a little tiny bit more, or at least coo a bit for me. What does this all mean for velocity? Since position was decreasing, we can say that velocity is negative. Or an easier way to think about that is that she was moving left or backward. Lastly, let's consider a situation where velocity will not be constant. So I'm going to get R2 to move across the floor here, and I want you to think about his starting velocity and his ending velocity and how they compare to each other, and what that might tell us about acceleration. Just to make things a little easier to deal with, let's make some estimates on starting velocity and ending velocity. Let's assume that starting velocity was 1 meter per second. And that probably makes sense because we're moving in a rightward direction, and it started off pretty slow. The ending velocity will also be positive because we're still moving in a rightward direction, but it's probably a bigger number. Let's estimate that it's 4 meters per second. What does that tell us about acceleration? Well, our strict definition of acceleration is positive when velocity is increasing. Did velocity increase here? Yeah, it went from 1 to 4. The last thing to consider is whether we're speeding up or slowing down. I think it's pretty clear from watching him move across the floor that he's speeding up. But another way to work that out is that the starting velocity is 1, so the speed started at 1, and the ending velocity is 4, so the speed ends up at 4. The speed increased, so we're speeding up. Another way to work this out is that velocity and acceleration are both positive. Or more generally, that velocity and acceleration have the same sign. In this case, they're both positive. Let's take a look at another example. Let's once again make R2 roll across the floor. And again, we'll think about velocity. So the starting velocity would have been pretty high there, the ending velocity would have been pretty low, but they're both positive. As estimates, let's say that the starting velocity was 4 meters per second, and the ending velocity is 1 meter per second. We can see that velocity decreased. It went to a lower value. So that means acceleration is negative. Was he speeding up or slowing down? I think it's pretty clear to see that he was slowing down. Mathematically, the way to reason that out is that velocity and acceleration had opposite signs. In other words, velocity was positive, but acceleration being negative meant that velocity was going down or getting smaller. Let's now look at another example where velocity is changing. In this case, R2 is going to roll from right to left. Once again, think about starting and ending velocities. I think it's pretty clear that his starting speed was low, and his ending speed was high. But those velocities are going to be negative because he was moving leftward. As estimates, let's say that the starting velocity is negative 1 meter per second and the ending velocity was negative 4 meters per second. In terms of speed, that means 1 meter per second compared to 4 meters per second because speed's the absolute value of velocity. Was he speeding up or slowing down? I think it's really clear that he was speeding up. What about acceleration? Remember that in one dimension, we've got these definitions. If acceleration is positive, then velocity is increasing. If acceleration is negative, then velocity is decreasing. Now, speed increased here, but velocity decreased. It went from negative 1 to negative 4. Think about if the temperature outside is negative 1 degrees and it goes down to negative 4 degrees. It has gone down, or the temperature's decreased. Here, the velocity decreased, so the acceleration is negative. We are not going to use the word decelerate ever. So here it's speeding up, and you might say, well, why is that? It's because the velocity and the acceleration mathematically have the same sign. They're both negative. And that will always take place. As long as velocity and acceleration have the same sign in one dimension, then we're going to be speeding up. Let's put R2 to work one last time. As we do this last run, think about starting and ending velocity, think about acceleration, and think about whether we're speeding up or slowing down. Here we go. Have you got your answers locked in? Let's check. Starting velocity and ending velocity are both negative. Okay? That is up until the point where he stops. The starting speed was bigger than the ending speed, so we could estimate that the starting velocity might be negative 4 meters per second, and the ending velocity is negative 1 meters per second. I think it's clear that he was slowing down. Again, you can reason that out by just watching him move. You can think about the speeds. The starting speed, which is the absolute value of velocity, was 4 meters per second. The ending speed was 1 meters per second, so he slowed down. Mathematically, what's going on? Well, we have to think about the acceleration. Again, positive acceleration means velocity is increasing. Is that what's happening here? Velocity actually is increasing here. You went from negative 4 up to negative 1. You moved upwards in terms of velocity. The number for velocity became a higher number. So acceleration here is positive, even though velocity is negative. And it's the fact that velocity and acceleration don't have the same sign that means that we're slowing down. They're sort of working against each other. Hopefully these demonstrations have given you a better idea of what positive and negative position mean, what positive and negative velocity mean, what positive and negative acceleration mean, and how they combine to tell you whether you're speeding up or slowing down. To recap, if acceleration and velocity have the same sign, either both positive or both negative, we're speeding up. If they have opposite signs, then we're slowing down. Just before we call it quits here, I want to mention two quick things. Number one, typically velocity is given as a vector. I decided not to put it in as a vector notation in this video for two reasons. Number one, we want to make this as accessible as possible to people who might not have much of a physics background. And number two, we're only dealing with one dimension here. So making it just a function that can be positive or negative seems sufficient. The other thing I want to mention are R2's controls. Right here, I've got the controls that I've been using. And if I push up here, it gives me a positive velocity. That means going forward. If I go to a negative value, that gives me backward motion. So these sets of controls really are set up to tell you about what positive and negative velocity mean. It's also worth mentioning that in order for R2 to change directions, velocity needs to, at least momentarily, be 0. In that way, times when velocity is 0 become sort of points of interest where we might have a change in direction. I hope this video has been helpful. Good luck with the material, folks, and take care.